Hello, everybody. We are back for day 2 of the 8.4 day 1 notes. I know that sounds confusing, day 2 of the day 1 notes, but again, I'm just chopping each note section into multiple days so that we can better understand this stuff as we do this virtual learning. As you can see on the top of the screen right now, it says have your trig relationship sheets handy. Make sure you have those up on your computer or printed out or written down or something. You're going to need to be comfortable with these. You're going to be referencing that sheet a lot. So make sure you have that out or none of this is going to make sense. Okay, today we only have 4 problems to go through. It's the exact same thing as yesterday, but it's kind of like yesterday on steroids. Now we're on to the more difficult ones of rewriting these trig relationships and trig functions. Okay, so on to number 5. When you look at number 5, again, the name of the game is just reduce what we can. We want to get everything in terms of sine and cosine, reduce, cancel, reduce, cancel. Okay? So right away, when you see a cosine squared and a 1 minus cosine squared, hopefully your bells kind of ring in your head, say, ooh, can I rewrite any of these as a Pythagorean relationship? Now, if you look on your trig relationship sheets, the third column is Pythagorean relationships. The first one under Pythagorean relationships says sine squared theta plus cosine squared theta equals 1. So which one, cosine squared or 1 minus cosine squared, has both a 1 and a cosine squared? The bottom. So we are going to rewrite this trig function, this Pythagorean relationship, sine squared theta plus cosine squared theta equals 1. We're going to move this over to this side and get it to be sine squared theta equals 1 minus cosine squared theta. So what does that tell us? That tells us that, hey, instead of this, we can put in sine squared theta. So we now have 1 plus cosine squared theta over sine squared theta. I'll put that in blue. Now, if you look at the reciprocal functions, you should see, well, I have a cosine over a sine. What is a cosine over a sine? Well, just cosine over sine of theta, that is cotangent of theta. Now, you might be saying, well, Mr. Arthur, these both have a squared in it. So is it legal for me to just go like this and say, well, cosine squared theta over sine squared theta is cotangent squared theta? Yeah, that's completely okay. So really, this whole fraction, cosine squared theta over sine squared theta, that's going to turn into 1 plus cotangent of theta. Okay, now this looks a lot simpler. 1 plus cotangent squared of theta. I forgot the squared, which was right here. So I now have 1 plus cotangent squared of theta. And again, we have a 1 plus something squared. That should be dinging in your head, hey, can I get a Pythagorean relationship out of this? If you look into the Pythagorean relationships, the third one, it says 1 plus cotangent squared theta. Again, 1 plus cotangent squared theta equals cosecant squared theta. That's it for the first one. The first one reduces down to cosecant squared of theta. Okay, on to number 6. Number 6 and number 7, I'm going to warn you right now, those are the most difficult ones on the page because they are fractions, and you're going to see what happens when we work with these fractions. So our job is to first turn everything into sine cosine, and then see what we can cancel. Rewrite in terms of sine and cosine, and cancel. So whenever you have a fraction like this, I highly encourage you to change it into the numerator and the denominator. So for my numerator, it's tangent of x plus cotangent of x. Well, how can you rewrite tangent of x in terms of sine and cosine? Well, that's sine of x over cosine of x. Again, that's tangent right here. Cotangent, I'll write in green, that's going to be cotangent is cosine of x over sine of x. And I still don't care about the denominator. I'm only working with the numerator right now. So under my numerator column, when I have sine x over cosine x plus cosine x over sine of x, if I want to smush these two together, if I want to make that one fraction, what do I need to do? Well, you should be saying you need a common denominator. You need a common denominator for both sides. We need a common denominator here and a common denominator here. Well, the blue one has a denominator of cosine. The green one has a denominator of sine. So my common denominator would be cosine x sine of x. So the blue one, I need to multiply by sine of x. So I'm going to multiply top and bottom by sine of x. The green one, I got to multiply that one by cosine of x. And again, I got to multiply the top and the bottom by cosine of x. Okay, so if I multiply the blue one, top and bottom, by sine of x, I would get sine squared x over sine of x cosine of x plus, if I do the green one times cosine of x, I would get cosine squared of x plus sine of x times cosine of x. Now, I can actually just combine these two together. I can say, well, oh, I'm running out of room here, holy cow. Since these have a common denominator now, this is the same, and this is the same, I can combine these two to be sine squared x plus cosine squared x over sine of x cosine of x. This is what I have as a numerator, but now you should be dinging, ding, ding, ding. I have a sine squared plus a cosine squared. If you look under your Pythagorean relationships, sine squared theta or sine squared x, same thing, theta, x, whatever they put there, it means the same thing. Sine squared plus cosine squared should give us 1. Again, that's our first Pythagorean relationship. So this whole thing, my numerator now, is just going to be 1 over sine of x, cosine of x. This is my numerator right there. Okay, now we need to do the same thing as with the denominator. However, the denominator is quite a bit easier here. Okay, so my denominator is secant squared of x. Well, what is secant squared reduced to? Secant is 1 over cosine. So secant squared x is just 1 over cosine squared x. That's what my denominator is. Now, I'm going to write this out. Some of us kind of see what's going on in their heads right now. But right now, if I combine my numerator over my denominator, so I'm going to put my numerator over the denominator, trying to color code. My numerator is 1 over sine of x, cosine of x. My denominator is 1 over cosine squared x. Holy cow, we got double fractions. This is confusing. But another way to write this again is, what if I didn't write it as a fraction like this? What if I put, instead of writing the division bar like this, what if I put divided by 1 over cosine squared x? And then all of this goes away. Well, now I have a fraction divided by a fraction. I can keep, oh boy, I can keep, switch, flip this beast. This would turn into 1 over sine of x, cosine of x, times, and now this guy flips. He flips to cosine squared x over 1. Well, now let's just combine them and see what we can do. So now I have 1 times cosine squared x. So that's just cosine squared x over sine of x, cosine of x. Now remember, cosine squared x, like 3 squared, is 9. You get that by 3 times 3. So that's cosine squared is cosine of x times cosine of x over sine of x, cosine of x. Well, now I have a cosine on top, a cosine on bottom. These cancel out. What's left? Cosine of x over sine of x. Well, now you're saying sine over cosine. Excuse me, cosine over sine, my bad. Cosine over sine, that reduces down to, under your reciprocal relationships, you should see that is cotangent of theta. This whole thing reduces down to cotangent of theta. Now, that is a lot of work. Let's kind of walk through again. I just want to talk about what we did. The first step is to separate it out between a numerator and a denominator. We did that. Once we separated it out, we only focused on the numerator, and we said, hey, these things have different denominators, so we're going to have to make them a common denominator. I multiplied the left by sine. I multiplied the right by cosine. When I did that, I was able to smash them together to make one big fraction. I had sine squared x plus cosine squared x over sine of x cosine of x. Went back to my trig relationship sheet and remembered that sine squared x plus cosine squared x is the Pythagorean relationships, and that reduces down to 1. Now it's 1 over sine of x cosine of x. From there, I reduce my denominator. Secant squared is 1 over cosine squared. I keep switch flip my fraction, crossed out what I could, was left with cotangent of theta. Okay. Number 7 is more or less the same thing. If I were you, what I would do is I would pause the video right now, try that on your own, and then if you get stuck, maybe watch up until a certain point, pause again, and keep going. Try these on your own. You will get better at it. Try to mimic what we usually do in class. Okay. I'll give you about 5 seconds here to pause. Just kidding, I just had to take a drink of coffee. Okay. So again, I have a fraction divided by a fraction. I'm going to divide this beast into a numerator and a denominator. My numerator is cotangent minus tangent. I'm going to move this over just a little bit so I have more room. Numerator. Again, you want to first change everything to sine and cosine. Change everything to sine and cosine. So cotangent is really, try to color code again. Cotangent is cosine of x over sine of x. Tangent is really sine of x over cosine of x. And again, we want to combine this into one fraction on top, so in order to combine these, we need a common denominator. Our common denominator is sine of x cosine of x. The one on the left, this one, for my denominator to look like this, I'm going to need to multiply it by cosine of x. What color should I do here? I'm kind of running out of them. This one, I need it to look like this on bottom. It already has a cosine, so I got to multiply this one by sine of x. When I do this, I end up getting cosine of x times cosine of x on top gives me cosine squared x over sine of x cosine of x minus, okay, sine of x times sine of x on top is going to give me sine squared x over, again, I have sine of x cosine of x. Now I am able, since my denominators are the same, this is the same as this, I can smush these two together, and I'm going to write this as cosine squared x minus sine squared x. And my denominator, again, my denominator is the same throughout. My denominator is sine of x cosine of x. Okay, now, a very common mistake right now, not even a mistake, I'm trying to get you to train your brain to say, ooh, cosine squared x, sine squared x. That's a Pythagorean relationship. But if you look at your Pythagorean relationship sheet, it is sine squared theta, or x. Theta and x are interchangeable. So sine squared x plus cosine squared x. If you look at ours, we have cosine squared x minus. So, in other words, we are not able to replace this with a 1 up top because the Pythagorean relationship is a plus sign in between and we have a minus. So, in other words, I am done right here. I can't change anything else on this problem. For the numerator, that is. On the denominator, we have, well, sine x times cosine of x. That's already in terms of sine and cosine. So I can't really do anything with that, can I? So what I'm going to do is I'm going to put everything, again, just like I did before, I'm going to write this in terms of the numerator and the denominator. My numerator is cosine squared x minus sine squared x over sine of x, cosine of x. Okay, my denominator is just sine of x, cosine of x. Now, if you look here, we have a fraction divided by a whole number. Back in number 6, when we got to this point, we had a fraction divided by a fraction, and we were able to keep, switch, flip it. Here, it's a whole number on bottom. Well, is there a way we could just make that a fraction on bottom? Could we make our denominator a fraction? Why don't we just put this over 1? So again, we could rewrite this as numerator divided by denominator, and then keep, switch, flip it. So I'm going to write this as cosine squared x minus sine squared x over sine of x, cosine of x, okay, divided by my denominator, which is sine of x, cosine of x over 1. Okay, now I'm going to keep, switch, flip this beast. I'm going to keep, switch, flip. So everything stays the same, just for time's sake. I'm going to change this to a multiply and then flip this to 1 over sine of x, cosine of x. Oops. 1 over sine of x, cosine of x. Okay, well, now what are we able to do? Well, the top, we just multiply straight across. We're going to do this times 1. Again, cosine squared x minus sine squared x times 1. That just gives me cosine squared x minus sine squared x. Anything times 1 is just itself. Now on bottom, if I do sine of x cosine of x times sine of x cosine of x, well, if I have sine of x times sine of x, that's just going to give me sine squared x, cosine squared x. Again, I have sine times sine, and I have cosine times cosine. Now, we have how many terms on top? We have cosine squared x minus sine squared x. There's 2 terms on top because of the minus sign. The minus sign tells me, hey, there's 2 terms here. On bottom, I don't have a minus sign. This whole thing on bottom that I'm about to underline in the yellow highlighter, that is all one term because there is no plus or minus sign in between. So what that tells me is I can separate this fraction into 2 separate fractions. So I'm going to take this fraction and pull it apart, so to speak. There's going to be this side and this side. So I can rewrite this as cosine squared x over sine squared x cosine squared x minus sine squared x over sine squared x cosine squared x. Okay, why does that help me? Well, now I can start canceling. Before, again, when I was at this point, I'll put another arrow there. When I was at this point, I couldn't just say, well, I got a cosine squared and a cosine squared, so I can cancel those out. I can't do that because this minus sign, there's 2 terms up top and only 1 on bottom. I can't just start canceling things out. Now, since I pulled this beast apart to 2 parts, part 1 and part 2, Now I have one term on top of both fractions. Part 1 has one part on top, one part on bottom, one term, excuse me. Part 2 has one term on top, one term on bottom. Now I can start canceling things. So in part, erase that, part 1 and part 2. In part 1, there's a cosine squared up top, there's a cosine squared on bottom. I can get rid of those. Part 2, sine squared on top, sine squared on bottom. I can get rid of those. Okay, what is left? Well, this side I have a sine squared x minus this side I have a cosine squared x. So what's left on top? Remember, it doesn't just cancel out and go away. There's a 1 left on top here, 1 left on top there. Now, one more easy peasy step and then we're finished. We can make 1 over sine turn into cosecant. We can make 1 over cosine turn into cosecant. So along the same lines, what we can do is just say, well, 1 over sine squared is, excuse me, 1 over sine squared is cosecant squared x minus 1 over cosine squared is secant squared x. That would be your final answer. I understand that's a difficult problem. That's probably the most difficult one we'll go through. If you followed along pretty well with that, you're pretty well set. Again, 6 and 7, those are the more difficult ones. But in order to do those fraction ones, you need to separate it to the top and bottom right away. Okay, on to number 8. Okay, on number 8. Number 8, again, we have a fraction. So let's separate this beast out into a numerator and a denominator. Our numerator is 1 minus sine squared theta. Our denominator is 1 plus cotangent theta. Again, I'm hoping those bells are going off in your head. Ding, ding, ding. Ooh, 1 minus sine squared theta. That looks like a Pythagorean relationship. The first one, can I rearrange my first Pythagorean relationship to look like 1 minus sine squared theta? You can. So this whole thing reduces down to cosine squared theta. Okay, 1 plus cotangent of theta. If you look at your trig relationship sheet, again, you need your trig relationship sheet out during this. If you look at the third one under Pythagorean relationships, it says 1 plus cotangent squared theta. Again, 1 plus cotangent squared theta equals cosecant squared of theta. Okay, well, what's cosecant squared? We want to put this in terms of sine and cosine. So cosecant squared, that's the same as 1 over sine squared theta. Okay, so now if I put my numerator over my denominator, what do I get? I would end up getting cosine squared theta over 1 over sine theta. So I'm hoping by now you can flip this in your head somewhat. So I would get cosine squared theta over 1 times, flip this bottom fraction, flip the red one to be sine, this is sine squared theta. I forgot to put that down again. It's sine squared theta. I'm struggling right now. It is sine squared theta. That's why I put the squared there. I forgot to write it initially. So I flipped the red denominator. I flipped 1 over sine squared theta to be sine squared theta over 1. Now I just multiply these two together, and I get cosine squared theta times sine squared theta. And that is it. Common mistake there would be to change, I have a cosine squared theta and a sine squared theta. I can just change that to 1. That's a Pythagorean relationship. No, you are not able to do that because a Pythagorean relationship would need a plus sign right there. We do not have a plus sign, so we are not able to do that. Our final answer is cosine squared theta plus sine squared theta. Okay, I understand this is a difficult note section. This is one of the more difficult things we're going to actually do, this entire online stuff. It just so happened that it was one of the next things up.